All right. So now we're welcome to welcome to First Discovery. So we're continuing with the Nix language tutorial at nix.dev, and we stopped at the with expression. I actually already recorded now an hour and a half, but there was a slight problem with the sound, and it's just I'm gonna record it again now. So I'm now going again through this tutorial. I didn't finish it. This is taking a while. And the examples here, I mean, you can do the tutorial, but I don't think you will. Well, it depends your experience with other languages. But like let's go with. Okay, the with expression allows access to attributes without repeatedly referencing their attribute set. Now, what does that even mean? So let A, so the examples are very abstract. So let A, so let's go out of this, right? And yeah, this third car, see, it's a big mess now. Oh, that's once you start naming things and you just have a bunch of names, then you know you have to sort it in your head. All right, so with, so let's go to an editor and let's do with. Do we have a with? No, we don't have. We have a with. Actually, let's remove the with and remove the inherit and inherit that color, and then remove the let, remove the strings, age. All right, remove strings. Now access add x with, remove x with. Yeah, I'm just removing. It's like really not really. Okay, so let the width. Let A is, and we have some keys and values, names and values. So let's do now cat names or cat age, maybe cat age dot nix. So let A is right. So we have like let A be, and this is a better. I saw this within Finicel. He declares really, let's see. So in, and we're gonna do with A. Okay, with A. All right. So this is actually better, and we have like a template, like a skeleton. I saw when Infinicil starts to write something, he makes like a skeleton and then fills it out. So that's much. I think that's very functional because you expand from the skeleton, not just let A this blah blah blah, and you write everything till the end and then you miss something. So like this, you build up on what you know, what's available. So like this is an empty skeleton. And now we'll just fill in the values. A is all right. So we're gonna say yeah. Oops. Yeah. So my first cat and age. So we said cat age. All right. So let's do Willow is 1. Both sisters, they all have 1. Let's do months, but they were born in the same month. Or their mom. Okay, Willow 1, Dandelion. Dandelion is 1. Kiwi. Kiwi is, I don't know, let's say 5. I'm not sure how old was mom. Let's do 5. Kiwi is 5. And with A. And now we just willow, dandelion, and kiwi, right? This is correct. Much better. First you write the skeleton and then I write names and values. So then, right. So then if I instantiate this, let me do this within helix. Nix instantiate cat age dot nix. Not a value to a derivation. Did I write this? Written. Nix instantiate eval cat age dot nix. Code, right? Yeah, it failed. Code this box here is like this is nice. I like this. Helix outputs like the shell, but what the output of the shell like in a box like this. With escape, you remove it, right? So we have code. So if we did sh nix instantiate eval strict, and we do cat age, so now we'll get the values 115, right? So the point of with, I guess, is just that you don't have to, you see, you can just with a willow, dandelion, and kiwi. So you don't have to do a willow, a dandelion, a kiwi. That's how I understand it. This is, I mean, yeah, it's kind of empty a bit now because we're not really applying it to anything that we. The expression a x y z is equivalent to ax, ay, az. So can we like check this in Nix REPL? Let's import. Let's practice importing, right? Be cool to check this. Can we just do it like this? With no, we cannot, right? I was like, I wanted to prove, like, I wanted to compare. Is this with a XYZ equivalent to this? Is this impossible to compare? XYZ, is that equivalent to X, Y, and A? Undefined variable, yeah, of course. Maybe if I import it, import cat age dot next, and do it now. Well, we have to with, yeah, no, this is too complicated. What I'm trying to do. Attributes made through with are only in scope of the expression following the semicolon. Yeah. Counterexample. Let A's x1, y2, z3, and B is with A, x, y, z. Z is x. What's going on here? What's the counterexample? So we're declaring the A set with the A set with x, y, z names and values. Okay, our collection of our cats. So the A set has willow, let's say willow, dandelion, and kiwi cats. That's the family of cats. In B, did we have a B? No. In B is with A, X, Y, Z, and C is X. So we could do B, undefined variable B. All right, we can call, it's like even calling this. All right, this. So it's like this. We can give it a name, right? The counterexample B is with A. So we can even in B is, we can give it in multiple top line expressions are not allowed. Why cannot we give it a name? Yes, we can. Wait. If we do this, no, we cannot. Maybe if we like this will work. It does work. Oh, you see, before we had 115. Before with the evaluated, it evaluated. Before, when we had only this, without the B, when we didn't put it inside of the B, it evaluated it. Said that's where we see the lazy evaluation. It evaluated Willow, Dandelion, and Kiwi as 115. But now when we put it, when we name it, when we bind it to a B, and we bind it to a B, it just outputs B is some, is some kind of a set. And now if we do Nix instantiated cat age, but we put strict and we ask it to evaluate it, it says B is 115. Okay, so can we do like can we do like C is with B? Can we call B unused with? C is X. What's exact? C is X. Oh, well, I don't have to do. C is B. Undefined name. Oh. I cannot like self-reference. But what if I do rec? We did this with attribute says. Wait a second, rec. This work? This work? Come on, will this work? It does work! Oh, this is cool. Finally, I'm using something what I already know. Repeated. It says repeated. All right, C is B and D is C, right? Because it's rec. Yeah, we're using rec. So let's do it again. D repeated, right? You see, right? Isn't that cool? Really cool. And so with C, Willow Dandelion, can we do like calculations? Calculations? I don't know, right? Okay, let's just leave it with this. This was nice. Yeah, I feel like when you do something like this, you apply something what you already know. You remember something what you already know. This really helps in learning. You just run the tutorial of what's written. I don't know. It's like really hard. But the problem was here was C is X. If it was written B, then it would work, right? That's why it says undefined variable X. You cannot like, you have to write with, but you cannot write with twice. Right now, inherit, I don't know. Yeah, let's move on. Inherit. Inherit is a shorthand for assigning the value of a name from an existing scope to the same name in a nested scope. It is for convenience to avoid repeating the same name multiple times. Inherit is a shorthand for assigning the value of a name from an existing scope to the same name nested scope. So like, what's the difference between with and inherit? This is for convenience to avoid repeating the same name all time. Let x1, y2 in inherit xy. This is a very subtle difference between with and inherit. So it will be like cat age inherit next. So let willow is 1, kiwi is 5. And inherit. Oh, I have to put it in a set. Inherit. Inherit what? Willow and kiwi. So like if I do Nia cat age inherit, get kiwi 5, willow 1. I get the inherit x y. Oh, I get the whole here. Reference x1 y2. Before, when I would write with, I would get the value. The will would get the value, right? And the inherit would get the name and the value. The fragment inherit xy is equivalent to xxyy. Okay. It's also possible to inherit names from a specific attribute set with parentheses. Example, A is x61, y2, and inherit A and xy. What's this? A is x1, inherit A. Okay, we need to like get age inherit. We can delete this. Let's do another one. Inherit cats. Nix. Names from a specific attribute. Let cats. All right. We'll do colors. Okay. Let sisters is gonna do willow gray, and we're gonna do format this. I don't know. Let's practice. What did we say? Let's practice. Let sisters, and we're gonna have an in, and we're gonna have a set, right? And we're gonna have an inherit. This is how you start, right? Inherit what? Inherit something. Inherit what? Sisters. This is a better way to write than just writing from the beginning to an end like some kind of a tape. This is more functional. This is functional. Inherit sisters. And now let's declare the value. I'm going to practice actually writing like this. So let's sisters, and you practice also your skills in manipulating, navigating with the text editor. So let sisters is willow is gray. All right. And do I write this in a new line? So willow is gray, and dandelion is brown. When dandelion is brown. All right. Hey, I forgot to put this. Yes, to put this in the big. So let sisters willow gray, dandelion brown, and inherit sisters. Inherit sisters So I put willow and dandelion. Right, yeah. So what are we having? Let sisters be willow who's gray and dandelion who's brown. In what? Inherit sisters, willow and dandelion. But what's the point of doing? Let's see. Let's evaluate it. Cat. Dandelion code, willow code. See, these are like silly examples now. And I'm saying this in the sense like if someone is watching this, you know, how do you get inspired to write code if you don't know programs, right? So you use these kind of silly examples, but it's you learn you learn how to manipulate, how to control data, but not directly, but like with code, like like magic of sorts, or like doing some kind of sci-fi teleport thing. Maybe this is weird what I'm saying, but Dandelion code and Willow code. So it's lazy evaluated. So if we do Nix instantiate inherit.nix strict, we'll get the brown, willow, gray. And if we go to REPL, like if we want to inspect this file, let's go to REPL and we are going to, like my file is import. Let's import this into my, so I'm binding this file to my file because you see, I can import it like this. I can import, this is the current directory and inherit cats.nix. So look, I just imported into a Nix read eval loop. Dandelion, brown, willow, gray. And now I can play with it in the REPL. I can play with it. Can I do like built-ins, attrib names? Wait, attrib names. And do I do like import? Inherit cats.nix? Will it work as built-in attributes? Nope. Maybe if I just do built-in names import? Nope. Maybe, yeah, you see, this is too direct. Let's import the file into a variable. So my file is, let's bind it, import, inherit cats.nix. So now if I write my file, I get dandelion, brown, willow, gray. I call that file, like I put it, like you write a paper somewhere, and now with my file, I get that paper. So I want to look inside of the paper, so I need to write a function that looks at it. So there are these built-ins. They are like built into Nix, built-ins, attribute names. So with attribute names, let's do my file. We got dandelion and willow, right? Let's like attribute names. It's like the way you look at names and you get them without looking with your eyes. This is important in code. That's how code binds together, right? So let's do built-ins attribute values. Attribute values my file. You get brown and gray, right? So then you can do, this is really basic, but then you can do further manipulations. And this will become handy when you start working with packages, right? And code. All right. So, all right, built-ins attribute names file, Dandelion Willow. And then what other like built-ins there are? Built-ins, I don't know. I know these two. I learned them now in the past hour and a half that I was recording. I'm not gonna upload the video that I just made, that I made before this one, because the sound is not right. Anyway, the fragment inherit a x y is equivalent to x is ax, y is ay. All right, so that you don't have to call it. This is like a function. Like a function. Oh, this is like a function that is applied. I don't know, you can do this in a REPL. You know, like when you have 2 plus 3 plus 4, you have 9. I don't know if you can do this. Plus and then 2, 3, 4. No, you cannot do that. Like prefix. This is like the prefix notation. So you put the operator before. But you can conceptually, you can understand this. You can put it like infix. Probably there's some kind of a way to put it in, I think with built-ins div. There's a built-ins div, yeah. Built-ins div 2, 3, 4, 5. Call something which is not a function but an integer. Built-ins div 2 and 3, 3 and 4. Ah, okay. Built-ins 2 and 3. Wait, built-ins div, let's do 10 and 5. So that's going to be 2, right? So the built-ins div is put at the prefix position and you divide 10 and 5. Let's move on. Is equivalent to, what's the time? 5 minutes, all right. Is equivalent to x. Okay, inherit also works inside let expressions. Let inherit, xy. Let inherit. So I think, yeah, the it's important to do it like, all right, let's do it. So let's do quit ls h inherit inherit let. Let's inherit let. So let inherit right, and in okay, so we have this structure. Let inherit in. Let inherit what? So we have willow is gray and kiwi is brown, and we just willow and kiwi, right? Is this correct? No. Oh, parrot. Wine. Parrot. Name. It's a lot of willow kiwi, willow kiwi, willow kiwi. That's kind of, that doesn't look so nice. Let inherit. Willow is gray, kiwi is brown. Willow kiwi and willow kiwi. That's too much typing. Let x1, x1, xy in xy. That's too much typing. Yeah, it's contrived. In a more complex code, you will regularly see nested let expressions that reuse names from their outer scope. How we use the attribute set x1, y2 to have something non-trivial to inherit from. The let expression inherits x and y from that attribute set using parentheses, which is equivalent to writing let x1, y2, x, y, x1, y2, y, and yeah, this is contrived. The new inner scope now contains x and y, which are used in the list x, y. The new inner scope now contains x and y. Kind of clear. Let's move on. String interpolation, previously known as anti-quotation. The value of a Nix expression can be inserted into a character string with a $ and braces. Let name is Nix and hello name. So yeah, this is like Nix REPL. Let name is willow in hello name, right? Nope. Yeah. Hello willow. right? Let name Willow in hello name. So you're referencing the name. You're calling the name. You're calling the name like this is your database of name, many names. Hello name. Hello name. What's the name? It's Willow. Hello Willow. Right. Only character strings or values that can be represented as character strings are allowed. So only characters are allowed. You cannot put a number. Except if you like put it in a string. Um, HX, HX, helix. Let's do internix. Internix, call it internix. So let, yeah, we said let in let so let name is Willow and color is age. No, let's do age, right? Because if you put age like 1, it wouldn't work. It would be an error because it won't work with integers, strings, with numbers. So, but if we put it in like a string, this with the, and we write hello name, you are age years old, age year old, or age year old, right? That should work. Someone's, and if we evaluate that inter next, hello Willow, you are 1 year old, right? So you see, you can do stuff like that, and that comes that will come later when in packages, and you can. But this is still like basic stuff. There's still not much functionality. It's kind of like linking things. This is like a link. This is just basic linking, but it's cool. It's cool, you know. A counterexample. Let wait, the mouse is like really counterexample. This is with the number. Yeah. Oh, this is like, do I need to have this? No, I don't need to have this. No, I need to hear myself. I'll just keep it like this if it works, because the ears are like, oh, having this for too long. Cannot convert an integer to a string. Yeah. Interpolated expressions can be arbitrarily nested. This can become hard to read, and we recommend to avoid in practice. Let A is no in A plus. Oh, this is complicated. No, we don't want this. No. Yeah, this is a warning. You may encounter strings that use the $sign before an assigned name, but no braces. These are not interpolated strings, but usually denote variables in a shell script. In such cases, the use of names from the surrounding Nix expression is a coincidence. Let out Nix, echo out. Yeah, this is just, you know, is a term to output it in a local directory or something like that. File system paths. The Nix language offers convenient syntax for file system paths. Absolute paths always start with a slash, absolute path // So this is like when you see a slash is like the main, like the world, the continent, the house, the room, and me. Paths are relative when you have this dot, which kind of means house. But where is the house? You know, so the absolute path would be you know, all the way to the world or to the universe. And so when you have a file in home, let's say in home, there are still there are still there are still directories above it, and the way to look at directories is better like spaces, like space above that contains the the directory below, like sets. Just as a house, outside of the house is country, or outside of the country. Where country is more like a conceptual thing. Outside of the house is the world. That's the absolute, right? So the relative, or like my room, and the outside directory is the house. It's more like a 3D kind of a thing than two-dimensional thinking from this directory to that directory. It's more like three-dimensional, go out and within. Current directory, relative example, relative path, one dot denotes the. Yeah, this is just basic stuff about paths. You will often see the following expression, which specifies a Nix files directory. Now, does this refer to some specific way that Nix does the file, or is this also? So this would mean current directory. Since relative paths must contain a slash, but start with one, and the dot denotes no change, the combination, this specifies the current directory. All right. Two dots, the parent. Two dots means like go up to the parent. Okay. Yeah, this is kind of, you can study that with like watching the how the file system looks like. Paths can be used in interpolated expressions and impure operational latest lookup paths, also known as angle bracket syntax. Example, lookup, Nix packages. Nix, so the lookup path, file system path that depends on the value of built-in Nix. Practice. Yeah, can you just like import it? Nix REPL. So we import Nix packages, lambda packages, impure Nix. Wow, what did I import? Built-ins Nix pack, built-ins. Wait a second. Let's let's do my path equals import Nix packages and built-ins Nix path, my path. All right, this. But you have this in if you have Home Manager installed, that's the, because Home Manager is a module, and like this is also a module, but that's why it looks different. I remember at first I was surprised, like why isn't it like this? But then you don't have a file, or why you don't import HomeNix into the imports. But so these are like two ways that you can do imports. You import a file.nix, which is a Nix expression, and you import lookup path. Yeah, the value of a lookup path is a file system path that depends on the value of built-in path. In practice, Nix packages points to the file system path of some revision of packages. For example, Nix packages dash slash lib points to the subdirectory lib of that file system path. All right. While you will encounter many such examples, we recommend you avoid lookup paths in production code, as they are impurities which are not reproducible. Indented strings, also known as multi-line strings. The Nix language offers convenient syntax for character strings which span multiple lines and have common indentation. Indented strings. Okay, this is simple. So you can write multi-line strings. Multi-line strings. Can I write commands inside, or just strings? Well, basically. But I could do like yeah, multi-line strings. So like Nix REPL. Right, see, this is a multi-line string. This is a line string. All right. Equal amounts of prepended white space are trimmed from the result. Right. Functions. All right. Functions. Functions are everywhere in the Nix language and deserve particular attention. Function always takes exactly one argument. Argument and function body are separated by a colon. Wherever you find a colon in Nix language code, on its left is the function argument, or the head, you could say, from the lambda calculus. On its right is the function body. So you have the head and the body, right? And that's it. That's a lambda. So you apply that to a value. So let's say, let's apply this to an apple. We get back an apple. So what we have here, it's a very simple function that gives you back what you give it. Like you could do it with y, it will still be the same, right? You could do it, look at this, you could do it even apple, apple, and you could give it a pear. So what do you think, what's going to be the result? Pear. Wow, this may look confusing because you see names are naming things. It's an interesting theme programming. So because it's like if I give you something and I give back something. So I could say if I give you blah blah, you give me back blah blah. It's the same meaning. If I say if I give you, yeah, but it's confusing because it's written apple and you give it a pear, but apple is a name. Pear is a meaning of that name, right? So let's say apple, apple, 2. So we get a 2. So maybe that's why, to not confuse people, people will put an X, like an unknown, 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 unknown 2. So what we have here is the identity function. Identity is XX. So now we can use it. Identity to identity apple. So can we compare things like identity apple? Is that equal with identity pear? Oh, it's false. But is it the same as apple? Yes, it's true. All right. So that's it, basically. But we can make more complex things, right? Let's define an ing. So like this, x and x plus 1. So now we're gonna call it with 2. So 2 goes inside of it's like the head is gone and the 2 goes inside of the x and the head is gone. So we have 2 plus 1, 3, right? So, and we can even do with more, x and y, x plus y, and now we have x and y, so 1 and 2. Hungry. Okay, 1 and 2, that's 3. We can go on, right? We can do x, y, and z. And then x, we can do more complex things, right? We can do x times, times y minus z. And now x is going to be 5, y is going to be 239, z is going to be minus 897. Oh, it doesn't work. Maybe because of the minus. Let's do minus 897. Right. Minus, we have to put the minus in parentheses. Look, it's a wonderful calculator. This is the lambda calculus. X, Y, Z. So you first declare in the head the parameters. It's going to, like our equation is going to have X, Y, Z. and X is gonna, that's how you can, I guess you can, let's do, what's the circle? R squared times P, something like that. What's this R squared, like circle area is what's R squared? R, we have an R squared and P, right? And P. And P, and what does it go? R times R, R, R times R, R squared times R times R, I don't even know. What's the circle area formula? I don't even know. Area of a circle, PR squared. All right, PR and R times P. RP, R times P, circle area. Ah, we can do it like this. Circle area R and P. All right, is RP. Will this work? Circle area. Expecting R and P. No. Maybe we can do it without. Oh, we can do it without actually. Circle area. Yeah, circle area. And now we have to give it an R. What's this? 5 and a P. 3.14 for 15. Yeah, circle area 5. So you see 78 times 5375. You see, we can do math. The lambda calculus. This is cool. All right. Enter value. Okay, let's see if this is correct. Radius 5. 7853. All right. 7853. That is correct, Mundo. Sorry. Function arguments. My things. Where, wow, it has a light theme and dark theme. Function arguments are on third way. The third way, apart from attribute sets and let expression to assign names to values, notably values are not known in advance. The names are placeholders that are filled when calling a function. Function declarations in the Nix language can appear in different forms. Each of them is explained in the following, and here is an overview. Single argument. X plus 1, that's an increment, right? Increment x plus 1. So we have inc1. We have inc1. We get 3 because inc is applied, like inc is applied to 1. We get a 2. And then inc is applied to that result of that inc plus 1, which is 3. It's kind of cool. Multiple arguments via nesting, x argument, y argument, and then we do x plus y. Attribute set argument, we have an attribute set and a plus b. All right, this is an attribute set. So we could do like hello and John, hello and world. No, wait, we could do like hello and world. Yeah, hello and world. And then hello. This is kind of silly. No, this is really silly. Wait, will this even work? Oh, this is really silly. Yeah, maybe if I do like a equals a is hello and b is world. So now can I do a plus b? Unexpected comma. Oh, I could do this. Unexpected, expecting. Yeah, this is wrong. With additional attributes, a plus b, named attribute set, args ab. Well, okay, these things examples are gonna come later. I think it's for IAB, args ab. This is just kind of referencing what's inside in functions have no names. We say they are anonymous. Call such a function a lambda. X is x plus 1. That's our increment that we named it increment, but now if you don't name it, it's just anonymous lambda. It's anonymous because you cannot call it again, right? If I do x plus 1, that's a lambda. Or if I apply it, x plus 1 to 2 to 3, I get a 4, right? But I cannot call it again. I have to write it again to call it on 6. Otherwise, if I name it inc, plus 1, now I have it. Now I can just use it and do whatever I want with it. This is the power of naming things and then call them. As with any other value, functions can be assigned to a name. What's the time? 51. As with any other value, functions can be assigned to a name. Example, let f, oh, now he's naming it within the f. Let f is x in, so it's anonymous, but like let f inc is x plus 1 and inc. That's not good. Oh yeah, x plus 1 semicolon and inc. So we have a lambda string at 1.11. It's anonymous because, oh, now we can call it, yeah, now we can call it inside, like let inc is x. Let's do a double. Let double maybe it's x plus x. So a double is a function that doubles the input. So if an input to x, right? If an input to x, let's do it like this first. X plus x, we do a double of 3, we get a 6, right? So the 3 goes inside here, the head goes, and 3 plus 3. So a double is thing that doubles itself. So let double is x plus x in double what? Double 5? 10, right? You can call it like that. Calling functions, also known as function application. Calling a function with an argument means writing the argument to the function. Need to get some water. All right. It's different when you record yourself like this, when you stream. Yeah, I talk much more than when I'm... Yeah, you see there are pros and cons. Pros and cons. Now I'm talking much more than when I'm learning without recording it. So it's different. Yeah, it's a different approach. Although there's value in putting thoughts into words. So you're making them a little bit more concrete, making a little bit stronger imprint. Yeah. Calling functions, or calling a function with an argument means writing the argument after the function. So let f is, oh, we just did this. So we just called it within the let expression. Yeah, okay, that's clear. 2. Example, let f x a. Oh, now I see. You're calling. You see, I didn't get this the first time. So it's like let double. Let double. Um, like this. Let double is x. Ah, he's putting x plus. No, wait. Will this work? X plus x dot. Wait, let's do it. Let f is x dot a. Right, a in f. So instead of f, the set and a is 1. So how would you do with the double then? Let f a is 1 and b is 2. So I guess it would be let f is, let's do x and y, x dot a and y dot b in f a 1 and do b 2. Will this work? Syntax error. Oh, but it didn't do anything. Ah, it worked. So let f x y x a y b f a1 and b2. What if we do like we do like, what was this split? No, we're not doing anything. Oh yeah, x a y b. Yes, we didn't ask it. Can we do like plus? So now a is 1, b is 2. This is kind of cool. We're doing the adding, right? But instead of just supplying the numbers, we are supplying a set that has these numbers. And these numbers have names. So there's an A that represents 1 and B represents. Will this work? Let, but we asked it. It's not adding it. 1 plus 2. But this is interesting. A little bit more clear now, actually. But why was this applied? Calls f on literal attributes. One can also pass arguments back. All right, let's do this. Let f. Let's do this actually in let's do helix eval apply. So we have a let expression and in, right? Feel like that. What are we going to do? F is what? Let's do an F function. X, okay, x dot a. This we are calling something. And what are we calling? V. So we're not going to say what's A. We're going to say V is what? V is A is 1. All right. All right. In what? FV. So V is going to be applied to F is going to be applied to V. Oh, we are getting an identity. This is an identity function. Oh wow. Wait, V. Can we instantiate this from here? Nix instantiate apply dot Nix does not evaluate to a derivation. Nix instantiate eval. I already have an eval. Nix instantiate eval apply. Right, it's 1. This is cool. So wait a second. If we try to do f is x, like a is 1, b is 2. How do we add b, a, b? Can we do like x? So y, b, a, and y. Right. So that means that we have to add here b is 2, b is 3. I don't know, b is 2. So will this thing work? Nix apply next. Doing 1. I didn't write it. Wait. Nix instantiate eval apply dot Nix. We got a lambda, so it works. Let's go out. And so near apply, we got a lambda. What if I do strict? Near strict apply. Still have a lambda, so it's not adding them. This probably has to do because it's an attribute set. How do you add attribute? How do you add element sets within an attribute set? Yeah. Since function and arguments are separated by whitespace, sometimes parentheses are required to achieve the desired result. X, that's what we did with the identity. X plus 1, 2. Question applies. Anonymous function. The argument function has to be written in parentheses to distinguish it from the argument. Okay. List elements are also separated by whitespace. Therefore, the following are different. Let f is x, x plus 1. Okay, that's our increment function. A is 1 in, oh, what's this? This is a list, fa. So this is applied to 1, right? 2, the list. Oh, this is like, this is what we did. This is what we did. This is like the increment in a file. Yeah, like this is what we did with we just did this and then we applied that to a 1. This is like you put that in a variable, f is this, and 1 is another variable, and then you apply f. This is the same. Now it's within a list, but this is within parentheses. Oh, this is different, the parentheses. So what's the difference? When it's in parentheses, you get a 2, and when it's a list, you get a lambda 1. Why do you get a lambda 1? Oh, because it's lazy. This is evaluated as lambda. Oh, it's not called. Why is it not calling a? Interesting. It's only evaluating the increment and telling you it's a lambda, but it's still not applying to 1. The first example reads apply f to a and put the result in a list. Okay, apply f to a because it's in the parentheses. Apply f to a and put the result in a list. The resulting list has 1 element. The second example reads put f and a in a list. The resulting list has 2 elements. Put f and a in a list and the list has 2 elements. One is a lambda function that increments and the other is second example. Sneeze. I think they have a button to remove the sound. Wait. Okay, I've just pressed the button again. I guess you can hear me. That's practical to have a button for like censorship. Like I can say bad words and just like press this. And now I'm back. Multiple arguments, also known as curried functions. Nix functions take exactly 1 argument. Multiple arguments can be handled by nesting functions. Such a nested function can be used like a function that takes multiple arguments but offers additional flexibility. Example, xy, x plus y. Debug function is equivalent to x. Yeah, this is, I'm not gonna go now into currying because I really want to finish this tutorial. No, but currying is fascinating and I think it needs time to wrap your mind around it. But basically, we are used to thinking like whatever I have, this is like I do one thing, and if I want to do 2 things, I make like there's a copy of me doing the second thing, and I am connected with my copy. It has to do with functional purity, and so this function x and y, so x plus y, is actually like this is a function that takes another function that adds these 2 numbers. So like this function adds the 2 numbers, like I don't know, you get like 1 like a part of the calculation, and then this number does the remaining part. This function takes 1 argument and returns another function y. Here is written with x set to the value of that argument. All right, example, let f is xy, x plus y in f1. Although this is partial application because f, we are calling this function that has 2 parameters or 2 arguments and adds them. But we're calling it with f1. So we get a lambda. Applying the function which results from f1 to another argument yields the inner body x plus y with x set to 1 and y set to other argument, which can now be fully evaluated. Let f is xy, x plus y in f2. All right. Yeah, this is currying is interesting, but it needs time to wrap your mind. Oh yeah, this is not sure why. All right. Attribute set arguments. The time 11. What's the an hour and 10? All right. I could stop now. Let's see where we are at. Attribute set argument. Attribute set argument. Oh, this is not even half. Attribute set argument, default values, additional attributes, named attribute set argument. Attribute set argument, also known as keyword arguments or destructuring. Let's just do this. Maybe just do this. Well, I want to see what's this. Attribute set argument, also known as keyword arguments or destructuring. That's a cool word, destructuring. Nix functions can be declared to require an attribute set with specific structure as argument. This is denoted by listing the expected attribute names separated by commas and enclosed in braces. Example. Let's see an example. A plus B. Yeah, we saw that. The argument defines the exact attributes that have to be in that set, leaving out or passing additional attributes in an error. Let F is A plus B, in F1 and B2, 3. That's what we tried to do before and it didn't work. Right. So we have like so let's go to Nix REPL and we do, all right, so we a function that has A and B. We do like hello, maybe we can do it with strings. Wait, let's try this. Hello and world, right? And hello plus world. I don't think we can add strings like this. This doesn't look right. Oh, you're declaring what's... No. Let's... Wait, what's the name of this attribute set? Args? Helix args Nix. Okay, let n. So the function has A and B, A plus B. What do with strings? A and B, all right. No, this and A plus B. Okay. So, and A is hello. We have to put it here. And B is world. Will this work? It does work. Hello world. let f is, you see, this may look boring, but work like this is so important. This didn't sound right. No, it's important to play with examples like this. It sticks better in your mind. Let f is a plus b. So the like the Nix code will use much more complicated examples. It's important to really see the structure. That's what I miss sometimes when I read the Nix code. Like you try to understand it, but it's like you're going here and there. You don't see the big picture. With functional programming, it's really important, like the way the code develops, the understanding develops. So you need to be able to expand the understanding from the general structure to an instance, to instances of that structure, like the let statement, let in, let f a b and a plus b, and f is a hello and b world. We can do it with numbers. All right. Maybe, yeah, maybe we can try, see, but the, why quit, right? A, B, and C, we like with cats. Added them. You could do string interpolation. Let name, oh, let name, we do this? Willow. Let's try this. Willow. F. Oh, cat1. Cat1 is Willow. Cat2 is Dandelion. So now we're gonna hello, hello, hello cat1, and hello cat1, and we could do hello cat2 variable. All right, let's do that. Hello cat1 and hello cat2. Let's see how this works. F, okay. So if we, let's try, like instantiate eval args.nix. Hello Willow, hello Dandelion. How are you? But we need a space after Willow. Like we can even use this, we can even declare space. That would be kind of, it's like a practice. Space equals this, right? Space is this, AB, A plus B. So that means A, B, and C. Do we need this? A, B, C, A plus B. Yes, we need this. A plus B. Does it have to be sorted? Maybe it doesn't. Plus C. So hello cat B. Hello cat 2. Let's B. Let's see. Let's try. C equals D, just like this. A hello cat, C, and B hello cat. No, this won't work. D equals what? D equals space. Space. Space variable. All right, C is the space variable. this work? Nix instantiate rx dot nix. No, hello Willow, hello Dandelion. The space. We have space at the end. Look at this. How do we put space between Willow and Dandelion? Hello cat. A is hello cat. 1. Oh, I don't have to do this. Wow, this is mind bending now. Wait. A is hello cat and B is hello cat 2. And C, how do I put space? Because yes, I could just put one space more, one space more in A or B, but I want to add space. It added space at the end of it, right? If we look at space, we have a space here. So that means if we go up, we do this. If we write this, right? Eval args.next. No, I know it. B because I have a all right. Let's try like this. Instantiate. No such command. Hello, Willow. Hello, Dandelion. Yeah, right. You see, we don't have a space. We added a space at the end of it. How do you add space between hello cat B hello cat 2? So it does sorting. I'm not sure how to add space. I would have to A hello. Do you see what I'm getting at? Cat 1, cat 2, F, A, B. All right, well, it's okay. It's okay to break your head sometimes like this. Counter example, F1, B2, C3. Okay, this is uncalled, yes, because we didn't declare it like we did with the C. Default values, also known as default arguments. Destructured arguments can have default values for attributes. I think we're gonna finish soon, but so I will probably be very short. Yeah, so I'll just see how much I go. Wait, let's see. What's the time? Hour and 23. That's okay. Let's just see. I'm so excited. Let's do default values. We have time. Additional attributes. Let's do just default values, also known as default arguments. These structured arguments can have default values for attributes. This is denoted by separating the attribute name and its default value with a question mark. Oh. Attributes in the argument are not required if they have a... I don't understand. Wait. Let's see the code. Always show me the code. Let F is A, B, A. So we have an attribute set with A and B and question mark and a 0. This is we just did destructuring, also known as keyword or this. We just destructured. What's the default? can have default values for attributes. Structured argument. This is denoted by separate attribute. F, A, and B, and question mark. A, question mark 0, B, question. What is this? You're giving the value? That's like the default value for attribute. Okay. So, like the default value of B, but what's the default value? Is 0. Yeah, I guess I don't have an example where I would see where it's really useful. Sometimes I could just ask GPT. Like, I get this, but I need a concrete example and mix packaging or something like that, please. In the context of Nix packaging, default values are quite useful for setting up packages with optional dependencies or configuration parameters. Let's say we are defining a Nix expression to build a simple software application that can optionally use a caching service. If the caching service is not specified, we might want to default to a dummy cache or no cache. Here's a practical example to illustrate how default values can be utilized in Nix expressions. Imagine we have a package called simple app that can optionally use Redis for caching. If Redis is not provided, the package should still be able to build and run without caching capabilities. This is a really long example. All right. Yeah, I don't know. All right, let's just default value. But it's something like if it fails on something that it has a default value, I guess. Yeah. Example. All right. F A0 B A0 A plus 0 additional attributes. These are, okay, let's do one more, huh? Additional attributes. Additional attributes are allowed with an ellipsis. Yeah, so it's like you can have this, you can have B, but also other things are allowed. Unlike in the previous counter example, passing an argument that contains additional attributes is not error. Oh. A, B, A plus B. In A1, B2, C3, get 3. All right, this makes sense. So it's like, you know, you declare A, B, and maybe some extra thing, and the function is like A, B, and I don't care about the rest. And in A1, B2, and C3. So you get 2. So you add A and B, not the C. But it's not a mistake because you put here 3 dots. All right. Named attribute arguments. It would be nice to finish here with libraries. Also known as at pattern, the monkey pattern. At syntax. Oh, it's not a monkey. An attribute set argument can be given a name to be accessible as a whole. This is denoted by prepending or appending the name to the attribute set argument separated by the sign. A, B at args. A plus B plus args C lambda. Args at AB, A plus B plus args C lambda. example, let f is AB. AB, three dots at args AB plus args C. Then it's adding all the three. So this looks very, like manual kind of a thing still. All right, let's stop here. Let's stop here. So we are at function libraries. Function libraries, and there is still much to go. This is a long tutorial. I'm taking a lot of time with this. All right. So bye-bye. All right.